looked at standard enthalpy of formation, we're going to move on and look at standard enthalpy of combustion. Notice that we've now got a little C at the bottom. And the standard enthalpy of combustion is about burning in oxygen. So how much are we burning in oxygen? So let's just have a little look at our equations. When 1 mole of a compound reacts completely in oxygen, so complete combustion, everybody's in their standard states. So we cannot change this number. This must be 1 mole now. And we're burning in oxygen, so we're reacting it with oxygen, which is a gas in its standard state. And what does combustion create? Well, we're going to create carbon dioxide and water. And the standard state of water is liquid and the standard state of carbon dioxide is gas. Pause the video and balance that equation. And you should have got that. So again, why don't you have a look at the next 2 examples and see if you can fill them in yourself. So you should have got that. If you didn't get 3 for number 2 for the oxygens, perhaps you didn't remember that there is an oxygen in the ethanol. So if you wrote 3.5, perhaps you forgot to balance properly. So there's a few more for you to have a go at here. All that is extra here is you have to remember the formula for the starting thing. So if you've managed those, that's what you should have got. Just watch out with the balancing in the methanol, and also maybe you weren't sure the standard state of methanol, but methanol is a liquid. So these are quite common questions. Just write an equation for standard enthalpy of formation, standard enthalpy of combustion. They're also very similar to in your first ionisation energy when you had to write an equation for that. The equation must match the definition. That's the key thing. So the definition says when 1 mole burns in oxygen, complete combustion, standard states. You've got to match those definitions. Let's finish off this video by having a go at some problem solving. So it says calculate the heat produced. Now heat is just measured in kilojoules. So we just want the heat in kilojoules, or maybe joules, but in this case kilojoules, produced when 240 grams of carbon undergoes complete combustion. So let's just have a look at this number. We've got a value here. It says when I combust, that's what the C says. So this little bit of maths here says lots to a chemist. It says that when 1 mole, because it's a standard enthalpy of combustion, when 1 mole of C burns in oxygen, the minus bit tells me that the energy was given out, released. The 393 kilojoules of energy were released. Now the minus is the released. If it was taken in, it would have a plus. So one little set of numbers and squiggles seems to say an awful lot. So when 1 mole of carbon burns in oxygen, 393 kilojoules of energy. So it's in kilojoules per mole. For 1 mole we get 393. So what we need to work out is how many moles is 240 grams. So moles is mass over mR, and carbon is 12, so that's 20 moles. So 1 mole releases 393. What would 20 moles release? You work that out on your calculator. Our next example says calculate the mass of methane that we would need to produce 4.45 kilojoules of heat when it undergoes complete combustion, and we've been told that it gives off 891 kilojoules released for 1 mole. That's what the number tells us. So we need to work out how many moles would we need to get to produce 4.45 kilojoules. So think to yourself, is 4.45 kilojoules bigger or smaller than 891? Well, it's an awful lot smaller, so we've got an awful lot less than 1 mole. Okay, so if we want to find out how much 4.45 releases, yeah, how many moles would that be? Then we're going to take our 1 Yeah, how are we going to turn that in? So, just delete that a minute. So we've got, 4.45. What fraction of 891 is that? That is 4.99 times 10 to the minus 3 moles worth. Remember that 891 was 1 mole, and we've got an awful lot less than 1 mole. So what mass of methane is that? So mass is Mr. Moles, and the MR is 16, 12 and 4, times by this number of moles we must have had, which equals 0.0799, or you might have rounded that to 0.08 grams. Now I wanted you to do that problem solving wise rather than with an equation, but if I tell you now that there is a little formula that says Q, which is heat energy, is delta H, which is enthalpy change, times moles, then that little triangle might help you out. But I wanted you to think about the problem and try to work it out with the numbers yourself.